I'm Xin-Yi. I'm from Stanford University. My background is mainly more of the physics of optics, but I've always been interested in like computational imaging and how AI can help optics or can help physics like basically advance in ways that physics alone might be probably like harder or probably it takes longer. Yeah.
I'm Ashok Veeraraghavan. I'm a faculty in electrical and computer engineering at Rice University, and my research is in building computational imaging systems for hard and challenging problems in all sorts of applications, from bioimaging to consumer imaging and environmental imaging and others.
So I guess like one question hearing this and also reading up about your background previously, I would like to ask like what perhaps made you interested in computational imaging or going into that field, because I understand that like computational imaging has quite a wide range, but I saw that you are doing like lensless imaging, like wavefront sensing and time of flight. So could I ask like what makes you go into computational imaging and why these aspects?
I think I can give you two different answers. I don't know which of them is actually factually true, but I think both of these answers played a part in my life. One of them is just timing, right? So I did my PhD mostly in computer vision and pattern recognition. Uh, Towards the end of my PhD, I did an internship with Ramesh Raskar at Mitsubishi Electric Research Labs, and somehow the problems that he presented to me had a lot more appeal to me, and they involved the signal processing background that I had, but also involved design elements that I found more interesting, rather than the analysis and analytical elements that were the core of computer vision and pattern recognition stuff. And so the interest in design naturally pulled me towards computational imaging. And so that's one reason why I think I slowly gravitated towards computational imaging. There is another reason, and that not reason per se, but another way that I view my own career trajectory, and that's at the heart, I'm an engineer. I actually don't know, I don't have a pressing problem to solve. Around me at my university, I work with a lot of scientists, and when I talk to scientists, they know what they want to solve. I actually don't know what I want to solve. I'm just an engineer. So I gravitate towards problems that I find interesting, but these are usually problems of other people. And so naturally, computational imaging problems appeal to me in that respect. And so I, as an engineer, I move towards that field as well.
Yeah, thanks so much. So when you say like you are trying to solve problems, so how do you actually get the ideas on what kind of problems you want to solve? Like perhaps do you speak a lot with like people from the different departments, or do you actually perhaps like try to solve real life problems that you see that computational imaging might be very helpful with?
I think the reality right now is all of the above. So problems come from all different places, and to find the best problems, I think my advisor used to tell me that one of the best ways to find good solutions is to come up with 100 different solutions and pick the top two. And I now think that that same attitude is also true about problems. It's to come up with 100 problems that need to be solved and then pick the top two. And so I am generally open to all of the above. So typically we look at papers in our field just outside and we say, what incremental progress can we make on this idea to improve upon the idea that's established state of the art? And a lot of our work is in that realm. But parallel to that, we have conversations with application folks. This may be bioimaging people that are interested in understanding how visual neuroscience of mice or monkeys. And so there they may give you a challenge in the form of, can you build an imaging system that has certain technical specifications which are conventional imaging instruments cannot achieve, and then we backtrack that into a computational imaging problem that we attack, right? So I think the third way we come up with problems is that I come up with problems is that I don't come up with them at all. I talk to my students, they come up with these problems, and then they tell me, here is a problem, it is interesting, I think we should work on it, and all I have to say is yes.
Oh, that's very supportive of you for your students. So I guess like yes, I think as engineers like problem solving is a very interesting area, but I guess like yes, problem solving is interesting, but I guess there will be challenges as like in this work as well. So perhaps like what are some main challenges that you might face in your work?
I think, I think in every project that you start, I'd say in the last, I don't know, 20, 25 years since I started being a graduate student, there's probably one or two projects where the results have exceeded my expectations. So the vast majority of projects that we work on, the results are not as good as our original expectations because physics and reality and all these things intervene, right? Like, and I don't necessarily think of them as challenges, but rather constraints that we need to eventually work with. So I think a certain sense of realistic expectations about what individual projects can achieve and how those individual projects feed into the research ecosystem so that we as a community can make progress, I think is important to move forward.
I see. Yeah, so I guess it's also about like setting expectations and having the right mindset.
Yeah.
Okay. So I guess like probably can I ask one last question? So perhaps like given like so like just in this field, what perhaps do you think is what some very important qualities or probably like the top 2 qualities or top 3 qualities that would be like important like in this field or probably just like research in general?
I think, especially to be an engineer and to be a good researcher, I think one of the most important qualities that one must have is to be an optimist and an illogical optimist. Because most problems that we work on are hard problems and they're not going to be solved in the next 20, 30 years. Now, there are 2 ways to address that. One is to say, okay, perhaps I'm not even going to be alive when these problems get solved. Why am I working on them? But as a researcher, we always think that within the next year we will solve the problem that we know will take 20 years to solve. And that's a discrepancy that I think is important for us to embrace. And so to be successful, I think one of the most important properties are things that we need to cultivate is to have this optimistic streak when we are addressing problems and to have a realistic streak when on the back side we look at evaluating our own performance over the last year or so.
Yeah, that's right. Yeah, thanks so much for your sharing. It's very insightful. Yeah, thank you.
Thank you. It was a pleasure talking to you.